So let's take next question. We have sec of x degrees plus tan of x degrees upon sec of x degrees minus tan of x degrees. Now, before I proceed with the question, I can observe there is a term sec minus tan in the denominator. And do you all remember that sec square x minus tan square x? The answer is 1, isn't it? We all know that from the basic identity, sec square x minus tan square x, it is given to us as 1. So if I take my question, I have y is equal to sec of x degrees plus tan of x degrees upon sec of x degree minus tan of x degrees. What I'm going to do here is I'm going to rationalize the denominator. Let's rationalize the denominator. So in the denominator, we have sec x minus tan x, isn't it? The degree is there definitely. So we are going to take care of that degree also in a short while from now. So at this moment we have sec x minus tan x, let us say. So I'm going to rationalize the denominator. So I'm going to multiply with sec x degree plus tan x degree. So in the numerator also, I want to write the same term, sec x degree plus tan of x degree. So what I'm doing here is I am rationalizing the denominator. So now if I rationalize the denominator looks like a minus b into a plus b, isn't it? We have a minus b into a plus b, and we all know that a minus b into a plus b, the answer is a square minus b square. So here also I'm going to get a square minus b square. And in the numerator, if you observe, it is a plus b and a plus b. So that becomes a plus b the whole square. So I'm going to write sec of x degree plus tan of x degree the whole square, isn't it? And the denominator becomes sec square x degree minus tan square x degree. So just now we have seen that the formula for sec square x minus tan square x is how much? It is 1. So the denominator straight away becomes 1. So the final thing that is left now is only sec x degree plus tan x degree, and the bracket has a square. So that's your simplified form of y. Originally y was quite big, isn't it? It was a little bit large function. What we have done is we have reduced it to sec x plus tan x the whole square. Now I'm going to differentiate both sides with respect to x. See, the differentiation is carried out with respect to x. You got to pay proper attention that we don't have x, we have x degree. So x degree and x, they are two different things. Whenever we are doing anything in calculus, x stands for radians. X is always counted in radians. Whatever question is written over here, wherever you find x, cos x, cot of x cube, sine of root x, sec x, tan x, wherever, whenever x is there for a trigonometric term, that x is always and always measured in radians. Whatever derivative, integration, limits, whatever we are going to learn, everywhere x is always taken in radians. If it is not given in radians, as in this case it was degrees, your first option, your first point should be to change the degree into radian. We will be doing it. Let's wait for some time. Before that, let's try and differentiate these things. So I have y is equal to sec x degree plus tan x degree the whole square. I'm going to differentiate both sides. So I write dy by dx is equal to d by dx of sec of x degree plus tan of x degree and the square of it, isn't it? So the derivative is applied to the bracket which has a square. The first function that you see is a square, and inside the square there is something of x, isn't it? Something written in terms of x. So I'm going to hide this entire term. I'm going to read it as u square. And what's the derivative of u square? It is going to be 2u and again derivative of u. So I get the answer as 2u, which is sec of x degree plus tan of x degree 2u, and then again derivative of sec of x degree plus tan of x degree. Got that? Now if I now see, I want to differentiate sec of x degree plus tan of x degree. So this contains what? This contains two functions connected by a plus sign, isn't it? That means I'm going to make use of the u plus v rule. Derivative of first term plus derivative of the second term. So what's the first term? It is sec of x degree. I know that the derivative of sec x is sec x into tan x. Is it sec x? No, it is sec of x degree. That means this is a function of x. Sec x is standard function. Sec x degree is a composite function because of the x degree. So I'm going to take x degree as u. So I'm going to read it as sec u. Likewise, the next term is tan u. Tan u, the derivative is going to be sec square u and again du by dx. So my next step, students, is going to be to write down the same thing as it is because no change with this term, and derivative of first term is sec x. Derivative of sec x is going to be what? Sec x into tan x, but that is not x, it is x degrees. So I'm going to write sec of x degree into tan of x degree into the derivative of x degree. Derivative of x degree. So that's our derivative of the first term. Then you write a plus sign, go to the second term now. Tan of x degrees. The derivative of tan x is sec square x. That's not tan x, that is tan x degree. So I'm going to call this x degree as u, and derivative of tan u is going to be sec square u. So I write sec square and u, and again derivative of u d by dx of x degree, and you can close the bracket over here. That's a big bracket over here. Now if you observe these two terms, you can take out the derivative of x degree, derivative of x degree. This term common, isn't it? So it's what you can say, slightly easier if I take the derivative of x degree and derivative of x degree common from the two terms. So I'm going to get here the terms as, and also you can take out sec x degree, one of the sec x degree common. So I'll be getting 2 sec x degree plus tan of x degree. Let's keep it in a bracket. From here, what things have come common? Derivative of x degree has come common. So I'm going to write it here. Let us say derivative of x, that is common, and also you can take out sec of x degree common from the two terms, and what is left? Tan x degree plus sec x degree. But tan x degree plus sec x degree is same as sec x degree plus tan x degree, and it is already present over here. So one more time I have got sec x degree plus tan x degree. I'm going to write whole square. Is that part understood to everyone? I have taken the derivative term common, and then there was a sec x degree common. I am yet to write that term. What terms are left? Tan x degree plus sec x degree, which is same as sec x degree plus tan x degree, and it was already present here one term, so I made it square. And what is common? You said it was sec x degree common, so take out the sec x degree common, and I'm going to write the derivative here. So derivative of x degree. Now my concern is to get the derivative of this term x degree, isn't it? So that's my challenge now. Although it's not a challenge in that way, derivative of x degree, it is quite simple. You just have to know the conversion of degrees into radians. If you know the conversion of degrees into radians, you can easily get the derivative of x degree. Now, for that purpose, what I'll do is I'll remove some of the questions which was written over here. I hope that you have already copied all these questions. We have taken all these questions in a very detailed manner. Please make sure that you go through all of these videos very thoroughly. Note down the solutions in your notebooks, and then let's proceed further. We'll remove some part from here. We are about to solve the second last question. We're going to complete it. So now, the left out thing is derivative of x degree. I'm just going to get it somewhere here, and then you can put that answer back in this particular step here. So derivative of x degree. Let's try and get the derivative of x degree. Now, since, as I said, it is again not x, isn't it? It is x degree. So you want to transform it into radians. Derivatives, you take limits, or you take continuity, or integration, or differential equation, any other topic in calculus. Every single time, if you have x, it is always in radians. Make sure it has to be in radians. If it is given in degrees, it is not allowed to differentiate. You have to transform it into radians. So let's do it. You know that 1 degree You have to remember this. 1 degree, we have learned this in our previous standards, 11 standard and 10 standard. And 1 degree is given by pi by 180 radians. I hope you all know this formula from your lower standards, people. 1 degree is pi by 180 radians. So therefore, if I want to get the value of x degrees becomes how much? Becomes a question mark. You can do the cross multiplication there. So that question mark multiplies with 1 degree, you get the question mark. X degree multiplies with this, you get pi x upon 180. So the question mark is replaced with pi x upon 180. That means I can say, if I now want to get the derivative of x degree, I can say that x degree is actually now what? Pi x upon 180. So pi by 180 is a constant term, so goes outside, and derivative of x becomes 1. So my answer is pi by 180. So the derivative of x degree came how much? It came pi by 180. Very contrasting result, isn't it? The derivative of x degree, some of the people usually think that it is something like x only. Derivative will be 1. So here is the big point you want to note it down, that x degree cannot be differentiated. It has to be first transformed into a radian. Once you transform it into a radian, then the things become quite easy. So x degree, I have transformed it into a radian, became pi x upon 180, and then I have differentiated it. The differentiation came pi by 180. So now I guess you can easily write down the final answer. It is going to be, I hope that's visible to all of you, 2 sec of x degree plus tan of x degree inside the bracket, then sec of x degree, and derivative of x degree, just now you have got is pi by 180. So at the beginning I can write 2 into pi by 180, the 2 and the 180 cancels, you get pi by 90. So that's how the question on degree can be solved. You have to note down, the first thing that I did was a rationalization of the denominator, because then the problem becomes quite easy. On the contrary, you could have used the u upon v rule to get the derivative, but it would have cost us too much time. That is how the problem can be solved easily if you note down, if you observe the question very thoroughly. So that was how we have solved the second last question. We will proceed towards the last question.